Okay, so again, we're going to start out with this differential equation, which you can replace f prime of x with dy dx, okay, so no big deal there. And at that point, you can separate variables by multiplying both sides by dx. That takes me to there. And then at that point, I've separated variables, so I'm just going to go ahead and integrate both sides. The antiderivative of dy is just y. On the right, you get this, which the 2's cancel on, right? And so you end up with this. So the general solution to this differential equation is y equals x squared plus c. No big deal, right? It was a pretty easy one. All right, now watch what I'm going to do from here. Once I find the solution, watch what I can do with it. Okay? Now again, since c can be any real number, like I said last time, this is what we call a family of curves. Okay, so the solutions to the differential equation are the family of curves. And so the only difference is that you would change the c each time. So let's just suppose I pick some c values. Let's just go with some positive and some negative and 0, okay, just to see what it's going to look like. So if I replace c with negative 2, I get that. If I replace c with negative 1, I get that, and so on. Okay, so I'm going to get these 6 equations, and when I graph them, I get this group of parabolas. Everybody with me? Okay, now, at this point, if I want to get a slope field, here's what I'm going to do. I'm just going to trace over this so you can see what happens. So I'm going to trace over the x and y axis right here. And then what I'm going to do is I'm going to draw a bunch of little tangent lines along these solution curves, okay? And I can sit here all day and do this, right? I can draw a bunch of curves and draw a bunch of these little tangent lines along some of those curves. All right, now when I pull away the curves, I'm left with something that looks like that. And that's called a what? Slope field. Okay? So that's one way to get a slope field, right? For a differential equation. Solve it. Try different c values to get the solution curves, and then just kind of draw the little tangent lines along those curves, and that gives you an idea what the slope field would look like for that differential equation. Now there's an easier way. Okay? There's an easier way, so watch. The easier way is to not even solve the differential equation. Just take the given differential equation. Again, pretend like I haven't even solved it yet. Okay? I'm just starting all over again. I'm going back to where I had the dy dx equals 2x. Okay, so with that in mind, here's what we're going to do. We're just going to pick some random points. Okay, so suppose we pick the point 0, negative 1. Okay, everybody agree the point 0, negative 1 would be right here? Okay. To find the slope at that point, well, isn't that what a differential equation is? Isn't that what a derivative is? It's a slope. And so if I plug in this point into there, how do I plug the point into there? Well, isn't this x comma y, isn't it? And so basically I'm just going to put in the x value of 0, and I get 0 times 2, which is what? 0. So I get a slope of 0. So here's what I'm going to do with that. I'm going to go to the point 0, negative 1, and I'm going to draw a short line that has a slope of 0. But you see what I just did? I just drew a short line there. Mirror, with me? You sure? What's that? Okay. Thank you. All right. And so I can keep doing this, right? I can pick another point. Suppose I pick the point 1, 1, which is right here. And again, that's x comma y, isn't it? And so if the derivative equation is 2x, basically I'm just going to be plugging in the x value only, and I'm going to get a slope of what? 2. So here's what I'm going to do. I'm just going to kind of estimate and draw a line with a slope of 2. Now if I made a 45-degree angle there for my little line, it would be what for the slope? 1. And so to make a slope of 2, I got to make it a little bit steeper than 45 degrees. Does that make sense? So maybe something like that. Okay? All right? And again, I can sit here all day and do this, right? And by the way, you should start noticing some patterns. In other words, what about all these points here when x is 1? Isn't x equal to 1 at all these points here? Isn't it? And so what's the slope going to be at all those points if x equals 1 and your equation only has x in it? What's the slope going to be at all those points? What is it going to be? 2. Okay, so I'm going to draw the same type of line at all those points. Yes? And then how about at all these points here on the y-axis? In other words, where x is 0. What's going to be the slope at all those points? 0. But you see what I'm doing to quickly get some other slopes at some other points? All right, how about at -1? We can do this one in our head. What about there, where x is -1? What's the slope? Well, don't you just do 2 times -1, which is what? -2. So a line of -2 would look something like that, right? Just, again, a little bit steeper than a 45-degree angle, right? And what about at all these points? Same thing or no? Same thing or no? Yes. Okay, what about at a point like this, where x is 2? What's the slope? Come on. What's the slope? 4. So it's going to be really steep, isn't it? And again, same thing at all these points. It's going to have a slope of 4. What about at all these points over here, where x is -2? What's the slope? Come on. -4. So again, it's going to be real steep, but negative, yes? All right, so that's another way to get the slope field. You see how I drew the slope field there? Okay, and by the way, did that kind of look like the other slope field I had up there a minute ago? Does it? Does it or not? It does, doesn't it? Okay, so you now know 2 ways to draw a slope field. What's the first method? What's the first method? Well, first solve the differential equation and then pick different c values, draw the curves, and then draw the little tangents along those curves. That's one way to get the slope field, right? What's the easier way? If you're given the differential equation, just plug in points and draw the slopes at those points. Okay? Got it? All right, so that's what we're doing today. And then I'm going to show you how they can test you on this on the AP exam. I've got a bunch of old AP questions for some of my examples. So here we go. Here's an old AP question right here. Pretty much all my examples are old AP questions. Okay, so here we go. What do they give you? Do they give you the differential equation or do they give you the solutions? They give you the differential equation. Now notice this time it has both x and what? Y in it. And so what they ask you to do is draw a slope field at these 12 points. See how they highlighted 12 points on the grid and they say draw the slope at those 12 points to get an idea what the slope field looks like? Are you following me? So what are you going to do? Just start what? Start plugging in points, right? Like for example, what's this one? 0, 0. So again, remember your slopes come from the differential equation, don't they? And so I'm going to put a what? 0 in for x and a 0 in for y, and that's going to give me a slope of what? 0. Everybody see I have to plug in both the x and y coordinates because there's an x and a y in my differential equation? You with me? And so what am I going to do? I'm going to draw a little line there that has a slope of what? 0. Okay, and so you guys, can I quickly get a bunch of other ones now? Anytime x or y is 0, what's going to be the slope? 0. So that means any point on the x or y axis is going to have a slope of 0. Do you agree with that statement? Yes? So put a slope of 0 there, 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 and a slope of 0 there. See how I can recognize patterns and quickly get a bunch of slopes? Are you doing this, Sam? Yeah? All right. All right, let's try some other points. What's this point right here, guys? What is that? 1, 1. So what's the slope at the point 1, 1? Yeah. Is it going to be a half at 1, 1? Yes? Okay, so here you got to draw a line that has a slope of a half. How am I going to do that? It's going to be a little bit less than a what? 45-degree angle. Remember, a 45-degree angle has a slope of 1, doesn't it? Okay. So maybe something like that. All right, what's this point right here? Quick. What is that? 1 comma what? 2. So at 1 comma 2, the slope's going to be what? 1 times 2 divided by 2, which equals what? 1. Okay, so there I'm going to draw a slope of 1. Okay, this one you can do in your head. What's that point right there? 1 comma what? 3. 1 comma what? 3. What's 1 times 3 divided by 2? Which is 1.5, and so that's going to be a little bit steeper than a 45-degree angle, right? Yes or no? Okay. All right. I think over here is going to be the opposite, right? This is going to be what? Negative a half, yes? What's this one going to be? Negative 1. So it'll be a 45-degree angle, yes? And what about this one? Negative 1.5. So a little bit steeper than a 45-degree angle. All right, so you see how I've drawn the slope field there at those 12 points? Okay, that's a typical AP question if one of these shows up on the free response. They'll give you a differential equation, and they'll want you to draw a slope field. Good? Yes? All right, now, I'm going to call on you, and you're going to answer B for me. See if you're paying attention. All right, how about, I don't know. Per rule. I don't know. Describe all points then. Oh, she's in here. I guess I should look up first. Brian's not here either. Okay, how about Sanya? Based on what you just learned here and what you saw when I was going through this, part A, when will you have a slope of 0? Or when, yeah, when x equals 0 or when, yeah, but when else? Look at your equation. X times y is 2. When's that going to be 0? Or x times y divided by 2? When x or y is 0. That's right. So how would I write that down? I'd say all points x comma y such that x is equal to 0 or y is equal to 0. Does that make sense? Okay? All right. Perry, you can help me on the next one. Describe all points where the slope will end up being positive.
All points x comma y such that either x and y are both greater than 0 or x and y are both less than 0.
Good. All points x comma y such that both x is greater than 0 and y is greater than 0, or both x is less than 0 and y is less than 0. Agree with that? Very well stated there. That's good, guys. All right. All right, and then how about D, Max? What do you think about D? Let me start it out. All points x comma y such that what?
Such that x is greater than 0 and y is less than 0, or x is less than 0 and y is greater than 0.
Okay, good. Again, well stated. All right, Sam, did you write all that down? Come on, you got to stay with me here. All right, so again, that's one example of what you might have to do if one of these shows up on the free response. Okay, now let me show you how this might show up on the multiple choice, and this is not as easy, okay? I think the free response ones are pretty easy if you think about it, but multiple choice ones can be tricky. Are you ready? Because again, it just depends on what they give you. So let's look at this old multiple choice AP question. What are they giving you, guys? They're giving you, this is not the entire slope field. This is just a piece of the slope field in the first quadrant, yes? All right, so what you want to do is you want to look at that slope field and say which one of the answer choices could be a specific solution to this differential equation. And so notice what they give you. They don't give you differential equations. They give you what? They give you what? Solutions, or possible solutions. And so how are the solutions related to the slope field? You tell me. Who can tell me so I don't have to pick on somebody? How are the solutions related to the slope field? Go back to page 1 and peek if you need to. How are the solutions related to the slope field? Yes? Okay. But graphically, when I had that slope field up here, how were these solutions related to the slope field? Were they what? What did you say? They do have the same slopes, but go more general. They what? Starts with an F. They follow or fit. That's right. Shouldn't the solution curves, when you graph them, follow or fit the slope field? Yes? So that's what I'm going to do. Ready? That's exactly what I'm going to try then to see if any of these would work. So here's what I'm saying. Let's check if A would fit. What does A look like? It's a what? Parabola going through what? Give me some points, quick. 0, 0. Let me use pencil so I can erase. So 0, 0. What else? 1, 1, and what? 2, 4. Okay. 2, 4 would be up here, right? So, okay, and again, I don't have to draw the whole parabola. I'm just worried about the piece of it in the first quadrant to see if it fits. Does that look like it fits those slopes? No. So it's not A. Agree it's not A? Okay. You see what I'm doing here? All right, what am I going to try now? You should all know what the graph of y equals 1 over x looks like. In general, what does it look like? It should be a what? It starts with an H. Hyperbola, right? In the first and what? Third quadrants? Yes? Do you remember that from Algebra 1? That was one of your parent functions, so to speak. Do you remember that you were supposed to memorize? Okay, so, all right, so you kind of have an idea that B looks like this, doesn't it? Yes? Isn't it a hyperbola in the first and third quadrant? All right, but let's get some specific points. Quick. 1 comma what? 1. 2 comma a half. And how about a half comma 2? All right, now what do you think? Possible, yes. Looks pretty good, yes. So I think B is a maybe, or maybe a yes. Okay, let's check the other ones. Now let me erase that and let me go to the next one. Okay, ln of x. You should all know what ln of x looks like. What does it look like? It goes to the point what? 1 comma 0. There's a vertical asymptote where? On the y-axis. And again, it goes to the point 1 comma 0, and then what else? And then it rises from left to right like this. Yes? Isn't that what ln of x looks like? Does it fit? No way. You agree it's a no? Okay, so it's definitely not C. Okay, what about D? You should know what e to the x looks like. What does e to the x look like? Well, e to the 0 is what? 1. What else? There's a horizontal asymptote where? On the x-axis. And then doesn't it rise left to right like this? Agreed? Does that look like it's going in the same direction in here? Yes or no? No, it's not D either. Okay, what about E? Well, what about E? Think of your unit circle to plot some points. Cosine of 0 is 1, so it goes to that point, yes? Cosine of pi over 2 is what? Think of your unit circle. Cosine of pi over 2 is 0. Now wait, pi over 2 is about what? 1.5? Isn't pi over 2 about 1.5? Yes? So right there is where it should cross the x-axis. About, yes? And then, doesn't the rest of it look like that, so to speak? You see what I'm doing? Yes? And I really don't care about the whole thing. I just care about this piece. Does that fit? Well, it kind of fits in here, but then here clearly the slopes are going in the wrong direction, aren't they? So do you agree it's a no? Okay, so what's the answer then? It's got to be B, isn't it? Yes? All right, so it's not E. So my answer here is definitely what? B. Got it or no? Got it? Understand what we're doing here? All right. Next one. All right, now they're changing things up on you. Another multiple choice, but instead of giving you the solution curves, this time it gives you the what? The differential equation instead of the solution equations. So how is that going to change your approach to finding the right answer? How is that going to change your approach? Well, you're going to go kind of back to what we did on that free response. You're going to pick points and look at the what? Slopes. So for example, let's think, before I start picking specific points, let's look at quadrants. Okay? Like for example, if I look at the first quadrants on all of these, what do you know about the points x comma y in the first quadrant? X and y are both what? Positive. So if I stick a positive in there and divide by a positive, I should always get a what? Positive slope in the first quadrant. Are these all positive? Yes. Are these all positive? No. So right away I can throw out B. You see what I'm doing here? Are these all positive? Yes. Are these all positive? Yes. Are these all positive? No. So just by looking at the first quadrant, I was able to throw out two of my answer choices. You see what I just did there or not? Are you with me? Make sense, Sam? Yes? With me? Sid? Make sense? Okay. Yes? All right. All right, let's try another quadrant. Another easy quadrant to try would be what? Quadrant what? 3 is easy, right? Because x and y are both what? Negative. And so if I have a negative divided by a negative in the third quadrant, my slope should always be what? Positive. Are these all positive? Are they? No. Are these all positive? Yes. Are these all positive? Yes. All right, so now I'm down to two choices, either C or D. All right, you can check another quadrant, and I think that might do it. Let's try the fourth quadrant. What do you know about the fourth quadrant? X is positive and Y is negative. So if you take a positive divided by a negative, you should always get a what? A negative slope for points that are in the fourth quadrant. Are these all negative? Yes. Are these all negative? No. Oh, what? Sorry. Let me say it again. Are these all negative? Yes. Are these all negative? Yes. So again, doing that did not eliminate one of those. So I think I'm done trying quadrants now. I should probably try some what? Some points? Okay. All right, so for example, notice this is 5 comma 5, yes? Right, and this might be like what? 1 comma what? 1 comma 1, this is what? 2 comma 2. What do you notice? Like when I plug in 1 comma 1, what's 1 divided by 1? 1. What if I plug in 2 comma 2? What's 2 divided by 2? 1. So along that line right there, the slope should all be 1. Do they look like they're 1 there? Yes. What about here? Like when I plug in 1, 1, or 2, 2, or 3, 3, or 4, 4, are those slopes all 1 along that? So what is it? What's your answer? C. You see how I did that there? Any questions? Not bad, is it? Okay, this is probably the easiest section of the chapter, but it's not easy until you understand what you're doing, right? All right, let me see if you can figure out 5 on your own. Go. Work on it. Yes. Yeah, I didn't even look at the second quadrant, but you could have. Yeah. Yeah. Got it already? Okay. That orange looks like it's had better days. not going to be all dried out. No? Okay. I can't even walk around with this microphone. All right, ready, guys? All right. So what's different about this one? This time they give you the slope field. And again, they give you what? Are these differential equations or are these the solution equations? They're the solution equations, right? Because they're y equals not dy dx equals. Is that clear? So how should these be related to the slope field? They should what? Fit, right? Along the slopes. And so let's just start trying things. Ready? Let's look at A. That's obviously a parabola going through what points? Quick. 0, 0. What else? 1, 1, 1. What else? 2, 4. Okay. All right. So the parabola would look something like this. So does that fit along the slopes? Well, it kind of does in here, but it definitely does not in there. Those slopes are going in the wrong direction, right? Agreed? So you agree it's not A? Okay. All right, so it's not A. Cross that one out. Try B. Okay, what does y equals e to the x look like? Well, e to the 0 is 1. And then there's an asymptote here, right? Yes? And then the rest of it rises from left to right like this. Yes? Agreed? Again, does that fit? Well, it kind of does here, but the higher you go, it looks like it's going in the wrong direction, right? So do you agree it's not B? With me? Heads up. I don't want you falling asleep. Heads up. So agree it's not B, everybody, yes? I mean, it was close, but I think it's still a no, right? All right, let's go to what? C. What is e to the negative x? Well, what happens to any graph when you multiply by a negative inside the function? It flips it over which axis? The y-axis. So instead of going like this, it'll go like what? Like this, right? Isn't that the e to the x graph flipped over the y-axis? Does that look like it's fitting through the slopes there? Absolutely not. So do you agree it's not C either? You agree with that? It's not C? Okay. Let's try D. So it's not A, it's not B, it's not C. Let's try D. Again, plot some points on the cosine curve. What's the cosine of 0? 1. What's the cosine of pi over 2? By the way, pi over 2 is, right about 1.5 because pi's around 3, isn't it? So you agree that's about pi over 2? What's the cosine of pi over 2? 0. And so isn't the cosine curve going to look something like this? And so on? And so really all we care about is this. Does that fit or not? No. Agree it's not D? Okay. All right. Let's check E just to make sure we didn't make a mistake earlier. Let's try E. What's the ln of 1 here? 0. What else? There's a vertical asymptote where? On the what? On the y-axis. And then doesn't the rest of the natural log curve look something like this? Does that look like it fits through the slopes? Does it? Yeah. So what's my answer here? It's E. I'm going to have, you see all these examples? I'm going to have one of each type on the next test. So these should be easy questions on the next test. Do not get them wrong. Is that clear? Okay? All right. Where are we? Sample 6. Really? Is that it? Wow. Okay. Why did I think this was longer? Okay. All right. Do you guys want to try this one since this is the last one? Okay, try it. And then we'll talk about it in a couple minutes. Again, take a look at what you're given and then take a look at what the answer choices look like. Yeah. differential equation can be used directly to get the slopes at any point, right? It's the solutions, like when they're in y equals form, that you would have to fit. You understand the difference between if they give you y equals or dy dx equals, right? Again, if I were you, I would try the quadrant approach first, because that can quickly eliminate some choices. So without getting the specific points, just try some quadrants. Like the first quadrant, you know x and y are both positive. See what that would result in as the slope, and so on. Yeah, I don't think you want to go to points right away, because I don't think you'll be able to eliminate too many of them using points. Do the quadrant thing first on something like this. Afraid to touch anything. You guys got it? You guys can see, I mean, there's some book problems and then there's some AP problems for your assignment. So if you're done with that last example, you might as well start on those extra AP problems. All right, are you ready? All right, let's go with the quadrants first. Everything in the first quadrant, in other words, every point in the first quadrant, x comma y, has a positive x and a positive y. So if I put a positive over a positive there, I better get a positive slope. And aren't these positive? So that's a possibility. But you guys, I think these are all still a possibility, aren't they? Because in all these, you're putting a positive over a positive, which would result in a positive slope. So looking at the first quadrant, do you agree I'm not able to eliminate anything? All right, let's go to the third quadrant. Okay, in the third quadrant, x and y are both negative, right? All right, so let's start thinking about that. What's a negative divided by a negative? Positive. Are these all positive like they should be? No. So everybody agree it's not A? Okay. What if you put in a negative and square it, put another negative in and square it? Don't you get a positive over positive, which is a positive? Yes? And so these should all be positive, are they? No. So it's not B. See how I'm able to quickly eliminate the first two answers just by looking at the third quadrant? Yes? Okay, how about here? When you cube a negative, you get a negative over a negative. What's a negative over a negative? Positive. So these should all be positive there, are they? Nope. Man, I'm already eliminating three choices, right? Okay. What about if here you cube a negative, you get a negative over a negative squared, which is a positive. What's a negative divided by a positive? A negative. So these should all be negative, are they? Yeah. So do you agree that D is a possibility? All right, let's look at E. When I square a negative there in the third quadrant, I get a positive over a negative. A positive over a negative is a negative, and these should all be negative then, which they are. So right now, it's still either D or E. Agreed? All right, now again, I don't know if you'll be able to eliminate anything looking at the other quadrants. So why don't we try some points? Ready? All right, what's this point right here? 3 comma what? 3 comma what? 1? Yes? And you know what? I'm not sure that's going to help. Yeah, I just kind of quickly did the math in my head. I don't think that's going to help. How about... You know what? Let's try another quadrant. Let's try this quadrant. Here x is what? Positive, and y is what? Negative. So if I cube a negative, or sorry, if I cube a positive, I get a positive. If I square a negative, I get a what? Positive. Positive over positive should be positive. So that's still a possibility. How about here? If I square a positive, I get a positive over a negative, which is a what? Negative. So these would all be negative, right, if it was E? So you agree it's not E then? So just by quadrants, I didn't even have to try points. The quadrants were good enough to tell me the answer is D. Everybody got that? Yeah? All right, so you can go ahead and do this AP problem. By the way, how are you going to do B? You're going to have to what? Take that differential equation and do what? How are you going to solve it? First, you're going to what? Separate variables and go from there? Yes? All right, so you've got that AP problem. You've got 3 AP problems. By the way, if you didn't notice, at the end of the packet are your answers to the AP problems. Hopefully there are no typos. Let me know if you find any problems. Okay? Got it? All right, so you can take a 5-minute break till about 8:07, and then I want you guys working. Do not waste the time. Do not get your chemistry back out.